Welcome to Engineers Mindset. Still on trying to fill this table. We're on row 6. We're on row 6. Okay. So once again, this is a column for the mass. Okay. This is a column for pressure. This is a column for temperature, volume, dryness fraction, degree of superheat, enthalpy, and internal energy. So for this row now, for row 5, we weren't given mass, so we have to look for mass. So mass is actually unknown. Let's put that down. Mass M is unknown. Okay. For that same row, we are given value for pressure. Pressure is given as 15 bar. So let's indicate that. Pressure equals P 15 bar. We were also given temperature. Now temperature was given to us. Okay, so given temperature, let's call that T given. It was given as 350 degrees Celsius. 350 degrees Celsius. Okay. We were given total volume. This is column for volume, and this is the row. Total volume is given as 0.15. Total volume. Okay. V equals 0.15 a meter cube. Okay. Now we weren't given dryness fraction, so we have to look for dryness fraction here. We weren't given degree of superheat. We have to look for degree of superheat. We weren't given enthalpy. We weren't given internal energy. So these are the 4 properties we need to look for. All right. Okay. So first thing first is to find the mass. Now we were given temperature and we were given pressure. So we need to first of all check, since we were given temperature, we now have to find out if this thing is superheated or not. Now to find out if this thing is superheated, we actually have to look for the temperature corresponding to this given pressure from the saturated water and steam. If this temperature is equal to this, then it means the steam is actually saturated and not superheated. But if the temperature is not equal, let's say this is greater than this, the given temperature becomes greater than the temperature corresponding to 15 bar from saturated water and steam, then it means the steam is superheated. So all we need to do now is look through the steam table. Okay, from saturated water and steam, corresponding to 15 bar. Okay, let's pick out the saturation temperature and see. Okay, once again, we'll look through saturated water and steam from the steam table. Okay, all right, so that shows saturated water and steam. Now we have to search out 15 bar. This is the column for pressure, as can be seen here. So all we need is 15 bar. Okay, take note, this is column for pressure, this is column for temperature. Okay, just right beside it. Okay, so we have 15 bar here. This is 16 bar. This is 15 bar. Okay, the temperature close to it is simply 198.3 degrees Celsius. That's the temperature column. So it means saturated temperature at that pressure is simply 198.3. Alright, so saturation temperature at this given pressure is simply 198.3 degrees Celsius. So since the given temperature is greater than saturation temperature, because given temperature here is 350 degrees Celsius. So since the given temperature is greater than saturation temperature at this pressure, then it means steam is superheated. And therefore for superheated steam, dryness fraction is 1. Okay, for superheated steam, dryness fraction X is equal to 1. So we can fill up that column now. Alright, dryness fraction X equals 1. Okay, that being said, we can now obtain the value for the mass. We recall we were given total volume. Total volume was given as 0.15 meter cube there. Okay, so therefore Recall total volume V is equal to mass times dryness fraction times volume of gas for the given pressure. So we look through the steam table again. Um, okay. So now, since the steam is superheated, we actually look through superheated steam table. Since we found out that the steam is superheated, everything we are going to obtain now has to be from superheated steam table. So from superheated steam table corresponding to the given pressure is 15 bar, corresponding to this pressure 15 bar, and the given temperature is 350 degrees Celsius. That's the superheated temperature is 350 degrees Celsius. Okay, so all we look now is have to be alright. So since the steam is superheated, we all have to now start looking at the superheated steam table to get our properties. So from superheated steam table corresponding to this given pressure 15 bar, the temperature must be the superheated temperature, which is 350 degrees Celsius. We need to obtain what is Vg. Okay, let's do that and see. So once again, steam table is divided majorly into two. We have the saturated water and steam. So we flip through to get to the superheated steam. This is superheated steam. Okay, now these are the values for given pressure. If you look on top here, you can see pressure in bar, and these are temperature in degrees under. Okay, meanwhile these are column for temperatures, different ranges of temperatures. We have 250, we have 300, we have 400, and so on. Okay, so we need 15 bar. This is 2 bar. Okay, um there you go. So you have here, this is 15 bar. Okay, that's the column for pressure. This is 15 bar. Remember the very first terms on top are what the values for the volume and the gas, Vg, okay, Ug, and the like. So on top the very first values are Vg, okay, Vg. So this is 15 bar. We look for temperature that corresponds to 350 degrees Celsius. So there is 350 degrees Celsius here. This is 350 degrees Celsius temperature. Okay, so which means these values are values that correspond to Vg at this temperature. The very first values correspond to Vg, as can be seen. This is also Vg. So we trace Vg corresponding to 15 bar. Okay, so trace Vg corresponding to 15 bar. This is 15 bar. Okay, so this is 15 bar. This is Vg corresponding to 15 bar. This is 15 bar, and this is Vg corresponding to 15 bar. Vg corresponding to 15 bar simply gave us 0.3865. Okay, so we'll put that down. So Vg and that pressure and at that temperature simply gives us 0.3865. So we have 0.6835 meter cube per kilogram. So this becomes the volume at the gas. Okay, and that given pressure and temperature. Alright, so from here now we can simply make mass subject. Mass becomes total volume V all over XVG. Okay, and this is now equal to total volume was given as 0.15. Okay, so we simply have 0.15 divided Vg. We obtain that to be this, so we simply have 0.6835. So this simply implies that this simply implies that mass is now equal to, it comes 0.22 kilograms. So this is the value for the mass. So let's fill that up. Mass is 0.22. Column row 6. Okay, 0.22. Okay, that's the value for the mass. Next is to find degree of superheat. Okay, this is a column for degree of superheat, and of course you know degree of superheat, DOX. Degree of superheat is simply what, superheated temperature minus saturation temperature. Okay, so DOS is equal to the superheated temperature was given as 350 degrees Celsius. That's the given temperature, which we had here, 350 degrees Celsius. Meanwhile, saturation temperature is the temperature corresponding to this pressure. We also find that to be 198.3 degrees Celsius. So simply minus 198.3 degrees Celsius. This simply implies that degree of superheat is equal to 151.7 degrees Celsius. So this is the value for degree of superheat. So let's fill that up. 151.7. Okay. Next is to find the enthalpy and the internal energy. So please take note, since the steam is superheated, okay, let me put that down here. Since steam is superheated, since the steam is superheated, then the values of enthalpy, okay, then values of enthalpy, specific enthalpy, sorry, then values of specific enthalpy is simply equal to Hg at the given superheated properties, that is P equals 15 bar and T equals 350 degrees Celsius. So specific enthalpy becomes what? Hg, and also specific internal energy becomes Ug. So you don't need to solve for this one, just simply pick out the values from superheated steam table. That gives you the values of the different enthalpy and internal energy. So all we need to do is simply want to convert them to total properties. Alright, so still same thing from superheated steam, table. Alright, corresponding to pressure is 15 bar and temperature of 350 degrees Celsius. Okay, corresponding to these properties, specific enthalpy H is actually what? Hg, and let's get what Hg is. Okay, so we zoom that up a bit. Alright, so this is still superheated steam table corresponding to 15 bar was here. Okay, this is 15 bar. Once again, this is the column for temperatures. This is temperature 350 degrees Celsius. So we trace it down to 15 bar. Okay, this is 15 bar. Alright, so this is 15 bar. This is 15 bar. So the value for Hg, Hg is the third line. If you can see here, Hg equals H. So it's written here boldly. Alright, so Hg simply becomes specific enthalpy at that what given pressure and temperature, since the steam is superheated. So we simply trace it down. This is okay. So this is 350 degrees Celsius. Okay, this is 350 degrees Celsius. Yep, 350. Okay, so that's 350 degrees Celsius. H is in simply 3348. Okay, as can be seen, this is 15 degrees Celsius, 3348 Hg. Hg is simply 3348. Okay, let's pull it out. 3348. So Hg equals 3348 kilojoules per kilogram. Okay, but this is a specific property, so we need to convert this to total property. Therefore, total enthalpy is simply what? Mass times specific enthalpy, and this is equal to, we obtain the mass. We obtain the mass as 0.22 kilograms. So we simply multiply here 0.22 multiplied by what we obtain for specific enthalpy, which is 3348. So this simply implies that total enthalpy H is equal to, that gives us 736.56 kilojoules. So this becomes the total enthalpy. Same thing, corresponding to this same pressure and temperature, we find value for specific internal energy. Okay, that's simply U. Obtain the value for specific internal energy. Still at that same property, still at those same conditions. So 15. Okay, so yeah, 15 bar internal energy, as can be seen here. Internal energy happens to be the second. Okay, so that's the second. As you can see, Ug here is simply equal to U. That gives you that tells you that the internal energy at the gas is simply equal to what? Specific internal energy under superheated conditions. So we'll pick out 350 degrees Celsius, which happens to be here. Let's just confirm that. Yes, that's it. Okay, so that's 350. So the value remains 26. So the value remains 2868 kilojoules per kilogram. 2868. So we'll pull that out. U is simply 2868. Okay, kilojoules per kilograms. Okay, so next thing now is to convert this to total internal energy, which is simply multiplying specific by mass. And mass give us 0.22 multiply 2868. That simply implies total internal energy is equal to 630.96 kilojoules. Alright, so let's fill that up. Enthalpy gave us 736.56. So we'll have it here 736.56, while internal energy U give us 630.96 here. Alright, so we'll have those two values. Alright, so that's it for that row and column.